Good morning. Uh, Today I'm going to present some information regarding the cement in the concrete technology subject. We have seen introduction regarding the cement and followed by types of cement. And now we are moving towards testing parts of cement. Generally, we have two types of testing. First is field testing and second one is laboratory-based testings. So first we'll see about the field testing of cement. So what are the types of tests we can do in the field, that is in the construction site. So first of all, when you receive a cement bag, you have to open it and you have to check whether any visible lumps is present inside the bags or not. Then the color of cement should be checked. So it should be generally greenish gray color. Then the next test is you have to thrust your hand inside the cement bag and you have to check whether it is giving cool feeling or not. If it is giving a cool feeling, then the cement is in good state. So if it is giving some irritation feeling, then it is representing that the cement is not in good case for the construction purpose. Then another test is you can take a pinch of cement with your fingers and you can just feel between your fingers. If you found a smoothy feeling, then you can assume that the cement is in good state. Then and the last test is you just take a set of cement, I mean few grams of cement, and mix it with take 100 grams of cement and mix it with water, and you just place this sample in a bucket full of water. So gradually you just place this sample and at the bottom of the container, so that while taking the sample from the top of the water to the bottom of the sample, the shape of the cement paste should not be disturbed. Okay. After which you have to wait for 24 hours. After 24 hours, you have to take the cement sample out from the bucket and you have to check whether the shape of the cement is maintained or not. If the shape is maintained, then the cement is in good condition. And at the same time, you can do a compression test to find the strength of the cement samples. So if the strength is attaining based on the IS guidelines, so the cement is in good condition and it can be used for the construction practices. If not, if the above said criteria is not met, then you can discard the cement sample and you can. So if the above said criteria was not met by the cement, then cement is not in good state. So you have to discard the cement and you have to buy the new type of cement for the construction activities. And next is laboratory based testings. So here we have few types of tests such as the fineness test, setting time test, strength test, soundness test, heat of hydration test, as well as chemical composition tests are available. So in the case of fineness test can be done by sieving the cement sample. So you have to take 90 micron sieve and you have to take 100 grams of cement from the cement bag. Randomly you have to take 100 grams of cement. Then you have to sieve it through 90 micron sieve. And if you found any lumps on the sieve, you have to break it with the help of your fingers and you have to sieve it continuously for a duration of 15 minutes. So after sieving, you have to check how many grams of residues are on the top of the sieve, and the residue which is on the top of the sieve should not be greater than 10% for ordinary Portland cement. If it is exceeding 10%, then the cement is not good for construction practice. And the next type of test is standard consistency test. So here you have to use Vickett's mold. This is the Vickett mold's image, this one. So here the Vickett is the person who formulated this test and who formulated this device. So the name Vickett comes from the inventor who invented this device. So here what you have to do is you have to take 350 grams of cement and you have to mix, say for example, approximately 24% of by the weight of cement of water you have to take it and you have to mix it and you have to place it in the Vickett's mold. And in the Vickett's mold, two types of devices are available. Say for example, one is plunger and another one is needle. Plunger is used to find the standard consistency and the pink color which represents the needle which is used for the finding the setting time test. So for standard consistency test, you have to lock the plunger in the Vickett's mold and you have to release the plunger and you have to check how much the depth of penetration of the needle. So if the depth of penetration is about 33 to 35 then the cement is then that is the standard consistency. If the standard consistency is not attained, says for example the depth of penetration is not up to 33 to 35 mm, then you have to add additional water. Says for example you have to additional water. Says for example you have to add 2% of additional water. Then again you have to repeat the same procedure. You have to mix it and you have to place the sample, the Vickers mold, and you have to release the plunger. And you have to check how much mm the depth of penetration of plunger to the cement paste. So this test has to be repeated until the depth of penetration of plunger is up to 33 to 35 mm from the top level of the scale. So if the depth of penetration is reaching 33 to 35 mm, so you have to stop the test and you have to mention this is the standard consistency. And this water is more than sufficient to make the cement paste. And next is initial setting time. Again, this type of test is also conducted with the help of Pickett's apparatus. Same 350 grams of cement has to be taken. And here you have to take water 0.85 times of P. P is nothing but the standard consistency of the cement paste. So how much percentage of water is being utilized for standard consistency? That into 0.85, that is 85%. That time, that amount of water has to be mixed with 350 grams of cement, and it has to be mixed thoroughly, and it has to be placed in the Vickers mold. So in the previous case, standard consistency test, we have used plunger, but in this case, we have to use needle. The pink color device which is attached to this Vickers mold, we call it as needle. So this needle has to be fixed and allow the needle to penetrate to penetrate through the cement paste, and you have to check how much the needle has penetrated from the top. So if the penetration of needle is 33 to 35 from the top, then it represents that is initial setting time. So if it is not reached, so you have to wait for another 5 minutes and you have to allow the needle to pass through the cement paste, and you have to check how much it has passed. Again, if not, you have to continue the procedure for every 5 minutes. Here you will not use any extra water. The water which you have used previously is fixed. So here only thing is you are just using the needle to penetrate for every 5 minutes. So until you have to repeat this experiment when the needle is penetrating to 33 to 35 mm. If it is reaching 33 to 35 mm, then that is the final, that is the initial setting time of your cement. Generally, the initial setting time of cement is 30 minutes for ordinary Portland cement. Then in the case of final setting time, similarly, Vickers molds has to be used. So here, in addition to the needle, we have to use some circular attachment, which is shown in this figure. See, this is a circular attachment. You have to attach to the bottom of the needle, and you have to allow this needle to pass through it. And you have to check the penetration is not more than 0.5 mm. If it is not going 0.5 mm, then the cement has reached the final setting time. So generally the final setting time of cement is estimated to be 600 minutes or else 10 hours for ordinary Portland cement. Then next is setting test, sorry, strength test. So in the case of strength test, you have to take cement sand ratio of 1:3, where you have to take 1 part of cement, that is 185 grams of cement, and 3 parts of sand, that is 555 grams of sand. And that has to be mixed with P by 4 plus 3% of the combined weight of cement sand mixture. That is the water. P is nothing but standard consistency of water which is required. Then by 4 plus 3% of additional water have to be mixed, and it has to be placed in a 7.06 centimeter mold. Okay, then it has to be placed in a temperature of room temperature 27 or plus or minus 2 degrees Celsius, and it has to be waited for 24 hours. It has to be set for 24 hours, after which you have to take the sample and you have to demold from the mold, and you have to do the compressor test in the compression testing machine, and you have to find the strength of the cube samples. Average of 3 samples has to be done to ensure the accuracy level. Then the next one is soundness test. Here the change in volume of the cement paste will be estimated. So for this type of test, we will use a device called Le-Chatelier device. This Le-Chatelier device is mainly used to check the presence of free lime also. In addition to the expansion, this is used to find the free lime. So here, this is the copper brass. Here, the lids will be attached. Lids A and lids A is attached over here. So bottom and top of this brass cylinder is open. So first of all, you have to place a glass like this, and at the top of the glass, you have to provide this brass cylinder, and you have to mix the cement paste. So for mixing the cement paste, you have to take 0.78 times of water required for the standard consistency. 78% of the p-value you have to take the water and you have to mix the cement with the same water and you have to place this in this brass hopper and you have to place the glass on the top of this brass and you have to place this unit inside a water container. I mean the container which is full of water, and at the same time you have to start heating the water. So you have to heat the water and within 25 to 30 minutes it has to reach the boiling point, that is 100 degrees Celsius, and the temperature has to be maintained for about 3 hours. After which you have to take the sample out and you have to cool it and you have to check how much the needle has extended. So previously the needle will be closely spaced, whereas after boiling the water, the cement tends to expand this volume, and after taking out from the water boiling, you can able to check the expansion of this needle. So if the expansion is grow more than 10 mm for OPC, this sample has to be rejected and you have to get the new type of cement for your project work. Okay, the minimum value of expansion should be of 10 mm. But in the case of expansive cement, it can extend more than 10 mm. The next one is heat of hydration test. Generally, when cement is mixed with water, it has a tendency to liberate large amount of heat. Say, for example, 1 gram of cement has a tendency to liberate 120 calories of heat. That much amount of heat is being generated. Whereas you just assume in the case of mass concrete construction, say for example dam construction, so large quantities of large cubic meters of concrete will be provided. So you just assume how much temperature being generated. So difference in temperature at the surface of the concrete and at the core tends to create the thermal incompatibility. As a result, cracking will be taking place. So in the case of dams, if cracking is happen, automatically water seepage will be there and finally it leads to collapse. So to prevent that one, people used to check the heat of hydration for each batch of cement samples. So actually this is the heat of hydration apparatus in which you will find how much amount of heat is being evolved. So the procedure involved for finding the heat of hydration is nothing but you have to mix the cement paste first, then after which you have to allow the cement paste to set, then you have to place the cement paste in furnace, the hardened cement paste in the furnace, and you have to set the temperature of 900 degrees Celsius for 1 hour. And after which, after attaining 900 degrees Celsius, it has to be maintained for a duration of 3 to 4 hours. So after that duration, you have to take the sample out and you have to cool the hot sample in a desiccator. And after cooling, you have to dissolve the cement in the nitric and hydrofluoric acid combination. And you have to check how much the temperature is being raised when mixing with the acidic mixtures. So, says for example, after 7 days, the heat of hydration should not be more than 65 calories per gram. And after 28 days, the heat of hydration should not be more than 75 calories per gram of cement. Okay, thank you.